you should record that. And then if you send that file to somebody, then you'll be all in.
Cool. Sweet. All right, so thank you for having me. My name is Andrew Smith. Work at version 1. I'm a developer there. Really awesome company. I'm also co-organizer of React Atlanta. I've got some contact information up here. Feedback is greatly appreciated, because I must say that this is not my first, but kind of close to my first presentation. So feedback definitely welcome. So what was mentioned previously about what we're going to talk about tonight is specifically React, Relay, and GraphQL. So you're probably wondering, why do I have 4 things up here and then only name 3? And so these 4 things are all kind of closely related to one another as far as the technology is concerned. However, we're only going to focus on React, Relay, and GraphQL. But I show that so you are aware that Flux is an architecture that's out there. It's kind of out of the scope to talk about. If you want to know more, if you happen to be going to Connect.js, I'll be speaking on it there. Or you could just, ping me or email me or whatever, and we can chat. So we're talking about React, Relay, and GraphQL. So originally, when we were going to do this, it was going to be Relay and GraphQL. So how many people here have experience with React? Okay. How many are using React in like their production environment or something along those lines? Cool. So we do have a couple people that are familiar with React. So Relay is not really relevant without React. GraphQL could stand on its own. But in order to talk about GraphQL in the context of Relay, we need to talk about it in the context of React. So I'm going to talk about React for a little bit and then dive into how Relay and GraphQL kind of relate to React and bring it all kind of together. So we have this question, developing web applications. How do we build JavaScript applications? How do we architect them? How do we organize them and structure them? So this is a question that is not trivial. And there's a lot of solutions and a lot of people that answer this question, specifically at least this many. Right? So here is not a all-comprehensive list of frameworks that kind of attempt in some way to answer this question, right? And so, yeah, there's a lot of them up there. I've used several of them, and yeah, they're out there. This is the thing. So what do all these guys have in common, though, is that they typically, most of them follow an MVW pattern, in model view whatever. So whether it's model view controller, model view model, model view presenter, which is I don't think is common, but essentially they all kind of have this consensus that MVC or MV star, so to speak, is the way to go. That's the way to write applications for the front end. It works. It's been around for a while and is kind of a best practice almost. And so most of the JavaScript side of things actually go with MVVM as their architecture, I suppose. So real quick before we get any further, I'm going to just throw this out there. We will be challenging some best practices in this conversation. And I will say that I feel like that's a good thing, right? Like best practices are the prime candidate to be challenged. There may be the status quo, they may be best practices, but if we take them for granted and without questioning them, then we kind of are doing ourselves a disfavor, right? So just throwing that out there right now. So all these different, I guess this is what this is. Yeah, all these different things right here, they all have one thing in common. They have models, like at the core, right? And so when you think about this, in the context of most of our applications that we build for the web, is a model is some chunk of data, and we want to get it to our view, essentially, right? So a lot of times there's maybe observables or subscriptions because we want the view to reflect the state of that model, all right? So when the model changes, the underlying model changes, we want to reflect that in our view in some way, and that's where two-way binding comes in with a lot of frameworks, is the way to facilitate that interaction. So with what I just discussed, there's another M word that comes to mind that is really important, and that's mutations. So in this particular realm, I suppose, mutation is kind of favored, All right, so just in describing the model concept, I talked about observables or subscriptions because things change and we want to reflect those in our UI. And realistically, like mutation is hard, it's complex, it's not easy. And if given the choice between two things, one was data that doesn't change, and the other was data that doesn't change, and also it can change. Intrinsically, the immutable side is less complex. Like there's fewer things to worry about. And so we have this notion that mutation is hard, and it gets really complex when we start dealing with views and stuff. All right? And so the question that we kind of have from this is there an easier way to handle this mutation? Is there a way that we can say, I don't want to, as a developer, I don't want to have to deal with mutation in my view. I want something simple. But of course, we still have mutations that occur. I mean, what application doesn't have mutation of data? Like, that just doesn't exist. So the question is there an easier way to facilitate this? And that's where React kind of was introduced. And just pulling from their page, React is a library for creating user interfaces. So specifically, React you can think of as the view. But it has, in some ways, an opinionated perception of what that means. All right? And so some of the hallmarks of React is that views are declarative instead of imperative. So that's really at the core of React, is that we have these views, these things that encapsulated pieces of functionality of UI, and we're going to call those components. And those components are going to be able to be composed together. I mean, which makes sense, right? As software developers, we're classically trained to take a problem and decompose it into smaller pieces, and then take those smaller pieces and add them together to solve the bigger problem. When I look at a UI, even before React came along, it's almost like immediately I start thinking, okay, this is like a little widget thing here, and this is a thing here. And I start breaking it down into these pieces just right off the bat. And so React really thrives at that type of scenario where we want to create components that are isolated and that are able to be composed together with other components to make a bigger and better interface. And then the most important thing that ties back into mutation and it being hard is it sports, so to speak, a one-way reactive data flow. So React works really well when the data that it renders is not mutatable. It's not impossible to mutate data within the context of React, but it's definitely something that you want to try to avoid. And so you may be asking yourself, how is that even possible? I mean, you have a view or a unit of UI or whatever, and you're telling me we're not going to mutate any of the data in it. We're just going to stick it in there, and somehow it's going to magically be our application and accept requests for mutations or whatever. Well, so they came up with a pretty interesting way to handle that, and I'm going to get to that in just a moment. So I'm going to talk about a little bit about declarative components and what that actually means. So if we have a text box on our page, probably looks something like that, right? Like it's an input, and it has a type text, it has a value, has some other properties about it, I'm sure. So let's take that example, and let's say I want to do an autocomplete text box, right? That's kind of like a little piece of UI that I want to be able to just drop in the page somewhere and use. So what would it be? I mean, in the context of HTML and what we're working with, you might think of it as something like this. It's an autocomplete tag, right? That is the component, that's the piece of UI, just like the input is a piece of UI. And it may have some other properties. It may have a search values that it has the pick from for the list, or it has the current value that is typed into the input text box. So this is what I mean by declarative components. And it's also worth noting that this syntax right here is what we call JSX syntax. It's not required to use React. So I'm just going to throw that out there. You don't have to use JSX syntax. If anything, you can think of JSX as syntactic sugar for a function invocation. But I promise you, if you use it for 5 minutes and then use the JSX for 5 minutes, you'll realize probably pretty quickly the nice things that this actually provides us for the readability of our UI. So what is a component specifically? I showed you that that was JSX syntax. It looks like HTML stuff, right? One thing to note is that a component has a render function. That is what renders the component. And in the example that I'm going to show, it's going to look like that the render function is returning HTML, because almost all of it looks like HTML. It's not HTML. So there's a gotcha that I feel like most people that work with React that probably experienced when they first started working with React is an HTML CSS class. You might say class equals my awesome CSS class. However, in the world of JSX, because this isn't HTML and it's instead DOM, we don't use class as the keyword, because in DOM, class isn't what's referenced for CSS classes. It's called class name. So there's some minor inconsistencies like that that could potentially trip you up, but just keep in mind that we're returning DOM and not HTML, and you'll probably be able to steer clear from most of those. It's also worth noting that components are descriptions of the UI. They are declarative, so they intrinsically are describing what the UI looks like given some set of input values. And that's going to be really important coming up into immutable UI. Talk about the immutable nature of how it's easier than mutation and how React kind of favors immutable data. So we can think of React components specifically as pure functions. So given some set of inputs, we always expect the same output. And that's really powerful. It's not only really powerful, but it also means that we can render this thing in multiple places, right? But I'll get to that in just a moment. I'm getting a little bit ahead of myself. So props going into a component are immutable. There is something that can be mutated within the context of a component that's called state. So those are the two big things, are props and state. It's advised to avoid state if at all possible in your components. And it's also worth noting that state is internal to that component specifically. So it's not externally something that you want to be able to expose. Both of which, any change to a state or any change to a property coming into the component is going to cause that component to re-render. So what that means is our UI, which is a component that has child components that each have maybe additional child components because we're composing them all together. You get this tree structure of components. And so what that means is this entire tree is going to re-render. In other words, your entire application on the UI is going to re-render on every single change of data, whether it's a prop coming in or a state change. And you're probably thinking, that's awful, because that's probably like the most expensive thing you can do on the client is manipulate DOM and render DOM out. So the creators of React, which was Facebook, they kind of realized this, and they were thinking, how can we essentially do this in a performant way? We want to be able to say our components are pure functions of our props going in. They're easy to reason about because given some state going into it, we know exactly what state is going to be coming out of it. But we need to be able to do it in a performant way. We can't just go about rendering the DOM over and over again. So what they ended up coming up with was something called the virtual DOM. And so what that is given a UI on your screen and a state change, whether it's a property going into some component or a state within a component changing. What React does is essentially takes the output of all the rendered components before rendering them to the UI, and it takes your current UI, and it does an intelligent diff on the two. So it's able to basically take out just the differences between what's currently on the page and the new UI that you want to be on the page, and it'll batch those updates and update the DOM in an intelligent way. So even though you're re-rendering everything, you're really only manipulating the DOM with just the pieces that have effectively changed. Another thing that I mentioned earlier that's also really important is the events in React. The event delegation happens after the render. And so this opens up really awesome possibilities because that means that the render can be done on the client or the server. So you can actually use your same components in both the client and the server. Like for instance, let's say that you come to a page and the page has some data on it in your React single page application, and you want to, instead of sending down a blank page and then having React bootstrap that data into the blank page, I want to send down like the actual page's markup and let React just connect to it, to the events that it needs. So that it enables that. That's really something that's pretty cool in the Node world. It's also worth noting that, and this is not within the context, scope of this talk, but there's also something called React Native, which allows you to use your same components not only on the client and the server, but in native mobile apps. So instead of rendering out DOM in a virtual DOM, it renders out essentially what the phone in question accepts as its native like layout mechanism. So that's cool, right? So
for like iPhone and Android.
So for iPhone is supported. I think Android is just come out. So iPhone and Android are now supported, although I don't know to what degree. I haven't used the Android React Native like mechanism, so I don't know if there's what the caveats are with it, but they both are supported at this point.
Does Facebook actually, is their app run off?
Yes, if you go to facebook.com and there, so React was, I think, just became release candidate 1, but essentially right before that it was 0.14 beta 3. If you go to Facebook's official site and look at the version that they're using, they are using React 14 beta 3. Like they definitely dog food this. They also are dog fooding Relay, which we're going to talk about in a minute, and Flux as well. Like they didn't just make these frameworks. So these frameworks, like React's been out for a little bit now, but you have to keep in mind that it's been used like for several years internally at Facebook prior to it being open sourced.
The initial iteration of it, I think, was to do stuff with like event notifications inside Facebook's web app and messaging client.
Yes, so it came about with I think it was the chat mechanism.
Because these events can come from browser-based or server-based, and they're trying to re-render this box that maybe you've got the app open on your phone and on your computer.
And you need to synchronize. So with that said, that's really coming into the realm of Flux. The ability to route your events through a dispatcher and kind of synchronize your state, your application state with your UI. And that's not quite in the scope of this talk, but I will say it's really cool. So at version 1 we use React, and we've just recently started using an implementation of Flux called Redux. We've been using React for, I don't know, maybe a quarter and a half or something like that. So fairly recent, but we've seen some pretty good success with it so far. You use Redux too? Yeah, I personally love Redux, but I'll talk about that later. So going back to our autocomplete example, right? So what does this look like? I've talked about React components, but I haven't shown really much like code. So I hope that this comes through on the dark background. But so one thing to note, this is ES 2015 syntax. So it's ECMAScript 2015, the next version of JavaScript. If you're using JSX to write your components, you're probably going to be using Babel to transpile them, in which case you will get 2015 features kind of out of the box with it. And React promotes the use of ES 2015 syntax because that's the standard going forward for its definitions of its components as far as classes are concerned and the modules, etc. So if you see things that you're not totally familiar with and you're like, wait a minute, that doesn't look like JavaScript, trust me, it is. It's just the next version. So here we import React from our React library. You see I have I'm exporting my class. So this is a module, and externally speaking, I'm exporting a React component, which is this class autocomplete, which extends React component. And you'll see I have a render method. That's really the only thing that's really important to have at this point. And so it's returning some DOM here. All right, so I've got a div, I have an input, I have an onChange handler here that's bound to this component, and then I have a lambda fat arrow function essentially that renders out the search list, which will be the results that you may see if you were to type in. Keep in mind this is extremely basic. It's not what I would recommend like implementing a real autocomplete, but for the sake of demonstration, I think it'll be okay. So the first thing you may know is like this guy right here, this onChange event. Go away. You might note this onChange event, and you're probably thinking like, at least when I first saw it, I kind of was like, wait a minute, whoa, that's not a best practice. Like I don't want to hook my events directly into my DOM, right? Like jQuery came along and helped us get away from that, right? Where we could attach them to multiple items at a time or whatever. Like we've evolved past this, right? But when you think about it, it makes sense because this component is isolated. Everything it needs is in here, which means this onChange event only happens like and is bound this one time. Like it lives where it belongs, essentially. And so if we were to look at the set value on that guy, it may look something like this. We were given an event from a normal JavaScript event, and we set the state. So I mentioned that internal state is typically you want to avoid it where possible, but it's not going to be something that you're going to be able to avoid at all times. So this is essentially going to set the internal state of this control or this component and say, I want my value in my state to be whatever I've typed in. So as I'm typing in, I'm setting the state as I go along. And that set state is going to cause a re-render of my component each step of the way. And then my search list over here, you'll see it was important. So you'll see I bound this right here because this function is not inside the scope of my class. I want it to be not exported out, right? Like no one cares about this but my component. So it's essentially private to my module. So I bind it to this in order to be able to access this component with the this command. So this is kind of a shortcut to doing that. The fat arrow function essentially doesn't mess with your this like a normal function scope would. So essentially, when I call search list, because it's inside, being called as a fat arrow function, you'll see that I'm using this.props, this.state. That's within the context of the component. It's also worth noting that this is also private because no one cares about this but me being the component. So it's that I've got my search values that I pulled in, that I pushed into it, whatever those values are. Whether they come from the server or come from a defined list or whatever, I don't care about that right now. And I get my value from my state. And then I go through and say, okay, well, I'll filter my search values for anything that looks like my value that I passed in. And if there is something, as in there's a hit, then I'll render out an unordered list. And for each one of these hits that I get from my filtered list, I'll render out the value in a list item. So pretty basic, right? Like we're going to get this input, and as we type, if we get something that matches some array that we pass in, we're going to get this really ugly unordered list with the bullets right below it. All right? So that's kind of what the autocomplete could look like if you didn't care about it looking pretty or functioning the way it probably should. So I mentioned previously about challenging best practices. And in the context of React, I feel like there's a lot of that could be had, right? So in our previous example, from the outside looking in, we've got JavaScript, we've got DOM or markup or HTML, whatever the hell you want to call it. We've got event binding, like right there on the elements. Like they're mixed together. Like what happened to the separation of our concerns? Like our model, our view, the controller or view model, like the separation of those guys. Like we came up with separation of concerns of those things for a reason, right? Like that's why it's the best practice. So I like this quotation. I don't know if it actually fits exactly, but I particularly like it. Plus, believe it or not, I promise you, this guy right here looks a lot like my dad. So because of that reason, I'm also pulling this quotation. And I promise you, I really do. Like growing up, I thought, he's also a math professor, which makes it even funnier, right? But anyway, so the quotation is we can't solve problems by using the same kind of thinking we used when we created them. So when MVC the solution was proposed or arrived at, it's not without its problems. And we can't solve those problems in the same thinking that we use to create the solution to solve some of those same problems. And so separation of concerns, in my opinion, really boils down to two things: coupling and cohesion. And we want essentially to have really low coupling and really high cohesion to be a true separation of concerns. And so just to kind of bring us up to speed, coupling is essentially the manner in which some component or module in a system needs another module. Like there's a dependency between the two. And cohesion is the degree in which something and a module belong together, right? And so I would argue that templates such as AngularJS, handlebars, etc., essentially not only are they not a separation, not only do they kind of, what I say the best practice for the separation of concern is there, like I think it breaks it. Like it's not a separation of concerns, not a true separation of concerns. And what do I mean by that? So here we have an AngularJS or handlebars view. We've got a table, we have some rows and some cell values, and we want to alternate the color of each row with some color value, right? So we've passed that in with what essentially is a view model here. And so our view model has data that our view cares about, specifically in the format that it consumes, right? And so here we have alternating color is blue. We have the rows. But the problem is both of these guys are depending on that same thing. They're very tightly coupled together. You can't really change the view model. You can't really change the view model and change this variable or like name or change things about it inevitably without changing the template that it's bound to. Because the two need each other. They are tightly coupled, not loosely coupled. Not to mention the cohesion factor, I would argue that they're kind of a different dimension of the same thing. Like essentially the view model and the view that is our template are kind of the same thing, like which is why they get coupled together like this. I mean, data in the view is no different than just the view with the data. If anything, I would say that these guys right here are more of a separation based on technologies than separation of concerns. Your template is in HTML, your view model is in JavaScript, your styles are in like less in CSS. Like we've separated these things out along technological boundaries versus separating them based on where they actually belong in the context of each other. And so the idea is to build components and not build templates, right? So templates, in the terms of React, templates don't exist. There are no templates. So the idea is we want to build, instead of a template that represents a view and a view model over here that represents the data that gets bound to that view, we want to build something that is holistically complete, that I can just drop in on any page and it work. And so coming back to what was mentioned previously about Flux, Flux is an architecture for building client-side applications. I'm not going to go very deep into this. I think it's outside the scope. But if you look at Flux in terms of like a diagram, you'll probably more than most likely see this or some really close variation to this online. And essentially, Flux is a single flow of data. So there's no two-way binding. Data only flows in one direction. It helps us better reason about what changes state in our application because essentially it only gets changed in one place. And so what I mean by that is we have a view, the user interacts with the view that essentially represents an action. I'm going to give like a really high-level view of Flux here. A view is our component. An action represents a semantic API for how we interact with our UI. So if we're sending an email or liking something on Facebook, these might be actions that represent like things that we can do with our UI. All actions get routed through a dispatcher, the single dispatcher, and then one or more stores get notified of every action that occurs. So the user store probably doesn't care about like liking a Facebook post, but the post store probably does. So stores get the ability to like decide what they care about, what actions do I care about, and this is where the mutation of state occurs, here and only here, in which case that new state gets pushed back into the component at the root level, which causes the props of their children to change, which inevitably causes the props of the grandchildren to change, which triggers the re-rendering of the entire page. And so we now have React components that don't mutate their state directly and are immutable pieces of UI. We're not going to talk about this, though, any further because that's a whole other subject. But there's a missing piece that you probably don't see online very frequently, and that's like getting the data from the server into our UI. Like, there's a server component here that has our data that somehow has to feed into this guy, right? And so that's where, if you work with Flux, or really UI in general, I think you probably will come to realize, like with RESTful APIs or APIs specifically for your view, that the server that's serving up the data and your view are kind of tightly coupled. Like, they are definitely reliant on each other. The view needs just the data it needs. The server has that data. If the data changes, I need to change the view, unless I'm doing some kind of funky mapping in between, in which case I have to update the mapping. Like, the two are intrinsically connected, right? And so that poses kind of a problem. So we're going to frame this in the context of a Twitter feed, right? So it may make a little bit more sense what I'm talking about. So here we have our Twitter feed. That's a component. It's a piece of UI. And then that's pretty much a list of tweet items, right? So each one of these is a individual tweet item component. And just for the sake of not having only two components and having like a little bit more in our thing, we'll say that we have a user info component that represents like who authored the tweet. All right? So our tree that I talked about earlier of components looks probably something like this. Our Twitter feed is at the top. It has children, which are tweet items. Each tweet item has an author, and it may have like an author for its retweets or something. Or maybe I have two here, really. I guess there's only one author, but pretend like there's two for the sake of demonstration. We have our network boundary, and we have our server. So if we were to this is what the tree looks like. If we were to color code this by where a color represents a shape of data, then we have something that looks like this, right? Our Twitter feed has a certain shape to it. Our tweet item has a different shape to it. And our user info has a shape to it different as well. Like, for instance, the yellow shape or off green shape might be first name, last name, and handle. Whereas tweet item might be, the tweet itself, the content. So we've color-coded these. That's great. But what does this really mean? So like this is where the problem comes in. Tweet item, Twitter feed, actually needs to contain the shape of its children in order to give them that shape for them to render properly. So tweet item, likewise, needs the shape of its children. Matter of fact, Twitter feed needs the shape of user info. Like, it's not even like a direct descendant here. It's somewhere way down in the tree. And that poses a problem. We essentially have a leaky abstraction going on here, where we have user info is bleeding into our other components. They need to know the shape. If I change the shape of user info to say orange, it sounds kind of weird to say the shape orange, but whatever, and I change it in my user info components, it means I have to change it in tweet item and in Twitter feed, and how to get the data right, I've got to change it in the server too. Like, I've got to change everything essentially to facilitate that simple data change for user info, which is totally not related to any of those other things. And that poses a problem. And so really what we want to do is take our shapes of data and roll them up. We want to essentially, just like we declare our components in our UI in a declarative manner, we want to declare like our data requirements in a similar manner too, a declarative manner. What does my component shape look like? And so what we end up doing is when we're able to declare a shape of data, and I'll show you how we declare it in a moment. What we can then do is say, okay, well, user info, we want to roll these shapes up. So Twitter feed essentially is going to ask tweet item, what is your shape? And tweet item is going to say, oh, my shape is this, plus it's the shape of my children, which is user info. So it ends up rolling upwards from the bottom, looking something like that. So we roll up our shapes of data by composing our declarative data requirements into each other to essentially get something at the top that we can then send to the server. The other part of this is having a server that knows how to handle that shape of data and that data shape changing arbitrarily. And so this is kind of a representation of our server kind of essentially able to respond to that shape of data. And once it responds to that shape of data, our components look exactly the same as they used to. There's no change needed. We just push it down as props like we would have already. The shape's already built in the way that we need it because we ask the components for their shape instead of trying to figure it out what the shape needs to be on the server. How do we do that? Like, how do we... That sounds pretty awesome, but how? And so that's where Relay comes in. Relay is a framework that is essentially a way to wrap React components in such a way that you can declare their data requirements in addition to their UI component itself. So it's specifically for React. It doesn't really make sense in the context of any other framework. It's essentially, it also handles the data fetching. So not only does it allow you to declare what your data requirements are, but going and getting that data and then giving it back to the component, it handles. Not only does it handle that, it does it fairly intelligently. So if you have part of the data, if you need a superset of that data, it will go fetch the difference of the data that you need versus fetching everything that you need. So it has some smarts to it, although I'm sure that it probably could use some work. And the declarative part comes in with GraphQL. All right? So what does Relay look like? Like, what do I need to do to my components that I already have to work with Relay? And the answer is essentially you don't have to do much of anything because the components are still just accepting properties going into them like they always would. The difference is we wrap that component in a container using like a container pattern and let the container worry about fetching the data to then push into the component via its props. So it looks more something like this. We wrap each component in a Relay container, and then the Relay container allows us to declare what the requirements are for our data inside of it. And then it pushes, when it fetches that data, it pushes that data into the component as a prop. So what does that look like? Specifically the GraphQL part. This is I'm going to talk about GraphQL a little bit more, but this is what GraphQL looks like, essentially. It looks like JSON, but stripped down, right? So a couple of things that this does. It allows us to declare our data requirements in a way that are similar to our React components. It's declarative. And it co-locates that data requirement with the component itself. I mentioned previously that the server and the view are in some ways inseparable. This is essentially not separating that inseparable part. Like the data coming in to our component that we need is now located in the one place that it's needed with the component itself. It allows us to also think of our components more in isolation. And the reason is because we don't care how the data gets there anymore. All we care about is given the data, given some state, we want to know how our React component renders. So it allows us to isolate it further than what we were able to do before. And it's also very easy to rearrange inside our component hierarchy. So I don't have to change, if I rearrange tweet item and info and swap them for whatever reason, I don't have to change anything like for my server. I don't have to change the shape of my data requirements because it's asking for those shapes automatically, essentially, to get them. And so that kind of brings me into, and of course it passes it into our user info as a prop. So this guy right here, what is that? Well, I guess I've got one more slide to go, sorry. So Relay, and just like some of the benefits that I mentioned, there's no subscriptions to your data model. This is actually really cool, and this is more of a feature of GraphQL. There's only one endpoint. So the API endpoint, there's one. And that API endpoint is able to respond with the shape of data that you need. So if you change that shape, it's able to respond to that change in shape kind of automatically. So I don't have a user's endpoint and then tweet items input API endpoint. Like I've got one API endpoint to worry about, and it can aggregate the data and slice and dice it in the way that I need it. It does query deduplication. So it has, I mentioned earlier, it's kind of intelligent about if it's a big query, it can batch queries together. It can collapse complex queries into simple queries, do the deduplication. It makes things like pagination pretty simple. Actually makes it really simple. It allows for a uniform way to mutate data. So GraphQL has a way to query for data as well as a way to define how it mutates. And so these are some of the benefits of Relay. So GraphQL, this is super important to Relay. It cannot work without it. What is GraphQL? So GraphQL, in the most basic sense, is just a spec. It's just a language spec. It's like a query language for graph data. In the terms of what we are going to be talking about, it is a server-side piece. And so there's various implementations that are available, but when we talk about GraphQL with Relay, we're talking about something that runs on the server. And then, of course, it's the single endpoint that I mentioned previously. So GraphQL predates Relay for quite some time. It's not something that came out with Relay. It's existed like 3 years prior to Relay. Like GraphQL has been, I remember quite some time ago with Facebook's API, describing GraphQL, and I thought to myself, what is this? This is some Facebook-specific something. I don't care about it, right? Man, do I wish that I cared about it, because I feel like I know more about it now, right? So it's been in production on Facebook for about 2 years, and they specifically invented it for native apps where data fetching can be expensive. And I'll show you what I mean by that in just a second. And it was recently open sourced, I think the same time Relay was. If it wasn't, it was really close. They kind of came out together, essentially. So I mentioned that GraphQL requires a server, and there's several implementations that already exist. I've seen one in JavaScript, I think a couple actually. I've seen one in Ruby, and I've seen one in C#. Now, I don't know how developed these implementations are. With it being as new as it is, there's probably some bugs. I wouldn't necessarily go as far to say the C# one, for example, is production ready. I don't know. It may be, but I don't know. So don't, take it with a grain of salt there. And you may be also thinking, with the GraphQL, what about RESTful endpoints? Another best practice that's been around for a while that we is the thing to do, right? And so challenging that best practice, I'll kind of end on a note with the inventor of REST, a quotation that I pulled from him, is that REST was really intended cross-organizational communication. But if you're within the context of the same organization, it doesn't make as much sense. And something like GraphQL makes a lot more sense in that context. So if it's a third-party external company needing to connect to your data, yes, REST makes sense. But if it's your UI connecting to your data and your server, all within your organization, ultimately all we're going to end up doing is fetching multiple queries for our REST and picking off some of the data we need, and then fetching from that data additional data because we didn't return the right amount of data. It just doesn't make as much sense. We want the data that our UI needs, which is more something along the lines of GraphQL. And oh, good. I thought I missed this slide. I'm glad. So this is what I was talking about earlier, the expenses of RESTful APIs. Overfetching, underfetching. If I have a Twitter feed, I get the tweets. Do I include the author graph, or is there an author endpoint and I just give me the ID? What if that author had its tweets? Well, if I return the author with my original tweet, do I then include those? Well, that doesn't make sense. I don't want to return all of his tweets. Well, where's that boundary drawn? It seems almost arbitrary. It's almost like intuition tells us, don't return all this data. But the problem is sometimes we want more data or we want less data. And it gets expensive when you have complex data requirements to make these multiple trips, where I make one trip to get my tweets, and then for each one of those I need to make a trip to get my authors because I've only got their IDs, and maybe the authors I need the retweets or whatever, so I make multiple endpoint calls to multiple endpoints, and maybe I don't even want all of the data that I get back for each of them. I only want some subset, but I am kind of forced to get the whole thing back anyway. Not to mention RESTful APIs, an application requirements change, they tend to grow in size as far as what you get returned. And a lot of times you'll find that RESTful APIs have like two versions, where you have like a compact version and a full version, which to me is just a code smell for like not returning the data that I need, not doing what I need it to do, essentially. So I have to choose, do I want the least amount of data, the most amount of data, and if you're in between, well, good luck, you just have to get more than what you bargained for. And that kind of makes it inflexible in general. I think this may be my last slide. No, it's not. Okay, great. So this is kind of like an overview of React, Relay, and GraphQL, how they work together. So you have reactive UI, components, declarative components. You have declarative data for those components. And then you have the server to support that declarative data definition with a single endpoint. I didn't talk much about Flux. Flux is another subject altogether. It's a little more involved because it's an architecture, right? So there's, depending on the implementation you choose, it could be a whole different discussion. But I am speaking at Connect.js on Flux specifically on October 16th. I don't know if there's still tickets available, but in the rare case, off case that there is, check it out. And if you're willing to drive to Midtown Atlanta, which I would not recommend on an afternoon for sure, I'm going to be in Atlanta. And I don't recommend going to where I'm going to have to go to speak here to drive, because the traffic's going to be horrible. But anyway, I'll be talking on React, but more specifically Flux, but it will be like a half, 30-minute type deal. And that's everything I've got. More plugs for Connect.js, because this is I mentioned earlier that this is my first-ish speaking engagement. So Connect.js will be my first conference speaking engagement. So please give me some feedback on if I was super boring or not or whatever. Just let me know. And I think that's all that I have. Thank you. Oh, are there questions? Sorry. You first.
So based on what you've said about being pure and sort of cohesive, so am I to understand it that React components, if you're not using anything else like Flux or whatever, two React components don't have a built-in way to communicate?
That's correct. So React is small in its ambitions of what it's meant to do. So there is no, that's what Flux actually is a way for components to communicate with one another. And to me, I've used Angular, but not nearly as much as React, so don't, I'm going to maybe say something out of line, I don't know. But for me with Angular, or not really Angular, MVC in general, when you have a composition of things, of views, and each view has a controller, and I do something on a child view, who owns that action? Is it the controller of the child view, or is it the parent controller? Well, what if the parent controller needs to know about it, but really the child controller that's connected directly to the view is the one that owns it? Well, now I have to communicate between my controllers, and I don't even know how many levels deep this communication necessarily goes, and there's not really a agreed upon defined way to facilitate that. And so within the context of React, there's not one either, but that's where Flux comes in, is it allows that communication to happen between components in a way that is easy to reason about.
This is a great presentation, by the way.
Yeah. Oh, thank you.
Yeah.
That was good.
In Angular, a lot of things are built around unit testing,
Mm-hmm.
and I guess some of the separation of the view and the controller has to do with, when you're building the controller, you're building a bunch of things that can be tested programmatically, whereas in the view, you have to use Selenium and load it up in a browser to really get at the things you need to test. How is testing dealt with in React?
So I will say that, I'll say that testing in Angular, you're not testing the view, the view potentially has code that needs to be tested in it too, right? There is conditional things that you can conditionally show something or not show something. So there's still a need for testing of, there's still a need for the testing of the view. It's just, it's impossible to get to unless you use Selenium at that point. So React, you could use Selenium. You can test React programmatically as well in two different ways. So a component, I mentioned, is just a function. So you can inspect upon that object that you get back, the renderable thing, and inspect like its state, its props, how it's rendering essentially. And React has testing utils that help you essentially like test on the DOM, but not. So it's still within the context of being in JavaScript. You're not firing up a browser necessarily. Well, I mean, you could, but I'd recommend not doing that. But essentially, it does offer ways to test, like holistically, the component, not just the state changes internally, but also like what does that mean to the UI? Because really, that's also just as important. And then if there's something that's inside the component that is truly like not UI related at all, I would argue that probably needs to be in a module that's tested that then gets used by your React component. So I guess to answer your question, there is quite a bit of support. I think Jest is like advertised as working really well with React testing, but we use Mocha version 1, and that seems to, in my opinion, do just as fine. Yes?
So I'm trying to wrap my head around some of the concepts that you introduced, and one of the things that you mentioned is, sounds like you're shipping. I studied Ember a couple of years ago, and at the time, the Ember approach that, as I understood, which I was very ignorant of it and didn't get very deep into it, and I know some of the things have changed, but we ended up shipping the whole payload at once. So it was almost like a single page application where you had to ship all the data over, and then from there you could do whatever you needed to do. And it sounds similar to what I heard here, is that you have that one endpoint, and then you can just ship all the data that you need or the right amount at a given time. Is that right?
So are you talking about on the initial render or after?
With Ember, it was on the initial render.
Okay. But there's a difference between the two in the context of this, and I was just wondering, like, I can answer.
Well, I guess what I'm getting at is like the thing that I focused on developing REST APIs for the last 4 or 5 years or so, and one of the challenges is that you touched on, which is that the versioning, you get into versioning issues as you say, oh, we need to add new functionality, and well, that's going to require new endpoints, and then if we have a client that's of this version, and so the REST solution for that is add more complexity. Let's add in your ability to determine. The clients need to be smarter about knowing what to do, and I'm sort of curious as to how React handles that. Like, if you're shipping over a big chunk of data, like somehow it knows what to request from that one endpoint, and the server is going to send back that right amount of data. But how do you handle versioning changes over time? When maybe the requirements for that piece, like your user info, let's say users used to not have their address, and now we're going to add in that address. How does that make sense?
I think it does. So on the React side of things, you would add the address as like a prop coming into the component. So it's an external piece of data going in. On the GraphQL side, you would then declare that address is part of your shape, whatever the shape of address happens to be. And then on the server, the GraphQL side, so there's two sides to the GraphQL. There's the client-facing side, which you just send the query and it gives you back the data, in which case it just kind of knows. And then on the other side, where it connects to your data sources, there's a schema that you define. And in the schema, you essentially say, this is how I get data X, Y, and Z. Okay. So GraphQL really, the big part of it is taking the query, the GraphQL query language, and mapping it to your data sources somewhere through a schema so it can respond to this shape of data. I mean, in some cases, it's not like magic. Like, you do have to, at some point, define, like, where is this data coming from? That's in the schema. But externally facing, you change the shape, it changes the shape of the data you get back. As long as it's in the schema, if I include address in the query, it will return me address. If I don't include it in my query, it just won't return address. Gotcha. And Relay specifically will do a diff on the client. I mean, there's ways you can force it, but to not. But.
So if you add like the address to the shape of the data in the Relay container, when it makes the query to the endpoint, as long as it's reflected in the schema, it'll return that updated
it'll say
data.
this action occurred that requires me to update these fields.
Okay.
Yeah.
Okay.
All right, that makes sense.
Yeah.
And what was I going to say? I don't remember.
And then I guess oh crap, I lost my question too.
I couldn't. I was going to say something too. I couldn't remember it. So
Yeah.
if you think of it, just let me know.
I think as a declarative statement, not a question, is the point you just touched on is ultimately like the key to this, in my opinion, is the explosion of endpoints. At some point, that occurs in your RESTful pattern, right? Yeah, or architecture. So this really facilitates like abstracting that away and not having that explosion of endpoints that ultimately happens.
Yeah, that helps. That helps remind me of my question too, which is there's implicit knowledge that occurs in that REST approach where the client has to know what endpoints are supported by the API, and that's what gets very frustrating. Is like the clients has to be
That's true.
that has to be updated, which is very difficult because that's where the versioning comes in. You're like, oh, we don't support that endpoint yet, and the client has to be smart enough about that. And so I guess that was sort of what I'm still trying to wrap my head around it. But how do you find that there's like a network effect? Like if you're using it, if you have a mobile a mobile phone client versus a web client, do you see like, oh, if we're going to do it in one, we might as well do it in the other? Is that sort of
What do you mean if we're going to do one versus
like
the
if
other?
you're going to use React on a web page with the client side JavaScript, you're going to look to want to do it on the
Are you asking like does Relay and GraphQL work in the mobile world?
Yeah, I guess I'm wondering like what if you have you as a developer you have to choose where you're going to spend your effort. So do you find you're like, okay, if we're using GraphQL, like if you introduce it into an existing legacy system, do you find you're like, okay, here it is, we've updated the web page, and now we're like, oh crap, it's really difficult to retrofit our mobile application. Do you find yourself going, let's rewrite all the things, or is it like a transition path?
I would say that. Well, I guess it depends on your circumstance, but I will say I would be pretty safe saying that I never would. But I mean. I think it's always evolving, right? But to answer your question, I think it maybe depends on like the legacy system in question.
Yeah.
So I mean, if you introduce a GraphQL endpoint, existing code, whatever endpoints they use could remain the same. New code, specifically if it's using like React and Relay, or even if it's not using Relay, it's just you want this ability to query shapes of data that the client defines, which is where the data requirements exist, right? GraphQL, as long as it's in your schema, it can serve up the shape of data.
Does the GraphQL server, will it just ignore things it doesn't know about? So like you don't have to.
I think so. Yeah, I believe so. I'm not 100% sure on that, but I'm pretty sure that it does.
Yeah.
I don't know if I haven't actually. Yeah, don't quote me on that. But I think that's the case.
So you mentioned how REST was more designed for external and external facing APIs. So does GraphQL ever make sense for being external facing, or are there concerns doing that versus?
So I think the reason that I would say REST is particularly suited for external is okay, so I'm going to speak from my personal versus like maybe what I feel, whatever. I kind of feel like the GraphQL makes sense externally too, but that's just me. I mean, like if I, as a client, I this is the data I want is this right here. Why do I have to go to this endpoint, and this other endpoint? I mean, because ultimately, like, what's going to happen is I'm going to go to these endpoints and get a superset of data and then trim it down on my side to get just the data I want. Like, I mean, why make? I mean, I guess unless it's like a system, like an integration to a system, maybe it makes more sense. I don't know. Do you have a comment for that, or?
Yeah, does authentication have any reasoning that would make APIs make more sense? Does GraphQL?
Oh, that's a good point. So I don't know if it has authentication built in. I think that would predominantly depend on the implementation. So I mean, I mentioned that GraphQL is like a spec. So there's like GraphQL JS or -JS. There's a C# one that's like GraphQL-.net. I saw a Ruby one. I've not used the Ruby or C# one before, but I imagine that the implementation of GraphQL and or something around that implementation would probably be responsible for the security. So I would think you probably could secure the endpoint in the same manner that you might in other endpoints.
It's something like OAuth would make perfect sense.
Yeah.
So.
Yeah, so I mean, but I've not done it personally. And I will say that GraphQL and Relay, like we don't use that at version 1. This is a little too new, although it's interesting. An interesting side note is we do have a adapter that we fondly maybe called Meta that does basically what GraphQL is doing, but it was written like 10 years ago or something, and essentially it's like a way to query like arbitrary shapes of data from our system. Although it's just version 1 specific, it's not like a specific like GraphQL. Kind of it's like a specification that could be applied across domains, right? But we've looked at GraphQL more, not so much to use it, but more so to try to learn from it and evolve our own. Although I guess we could potentially use it, but kind of learn from it. Like we already have something similar. What can we learn that we didn't do that GraphQL did? That kind of thing. So we're not using this in production currently or anything like that. But yes.
What about, I'm not a developer, so maybe I just tuned out a little bit. Caching of any kind with GraphQL, is it?
So that was a question that came up, I think, last time. I don't know how GraphQL does the caching.
But it does have something.
I think all your regular HTTP expiration headers and caching headers should still.
I think they will still apply, but I don't know. I can't speak well enough to it to really say like one way or another like confidently. I'd have to look into it. I suspect that the caching is probably once again outside the because GraphQL Server I think its purpose is to translate a query into data, and so it's not really its purpose. And I guess some of that caching can be involved with the data caching, but like caching as far as like over the network is concerned, it's not really its responsibility. Although Relay does do a pretty decent job figuring out like the data you need versus the data you have currently, which helps, right? But how it caches like on the other side, not the client-facing side, but when it goes to get your data, I'm not sure. I think that's probably something configured in the schema and is specific to the implementation.
Conceptually, different components within the HTTP response would have different expiration times. So your user info might expire at different times, and your tweets might expire for instance.
Well, that's the thing. Like, it sends one request for like all of the shape of your data.
Yeah.
So the user info and the tweet item and the Twitter feed, it wraps all the requirements for that data into one request and then sends back whatever the data is that you need that you don't already have on the client.
But suppose the client already had tweets for the username from one of the tweets. It's not going to request the data for that because it already knows it.
Yes, that's correct.
Because it might have.
Oh, I see what you're saying. Yeah, I don't.
It might be cached.
Yeah. And it kind of goes back to I don't feel like I can't really speak to it
I'm just
quite well.
How it might work. I have no idea how it actually works.
Yeah, I don't either. I really don't.
Caching expiration was part of that model container.
I'm not sure. Any other questions or? I don't know how much time. I don't know if I'm running out of time or not. I haven't even been paying attention. That's not too bad.
All right.
Cool. Thank you.
Like I said, next month we're doing the student showcase. Going to try and get some student projects here like we had in April. And then I forgot to say, the 13th, next Tuesday, Athens Women in Tech, Aaron Miller is going to be talking about